Hello everybody, this is the first video from the series Virtual Reality for Education. It is often difficult for learners to work with 3D diagrams. This is not surprising. 3D diagrams are usually shown in 2 dimensions, on a flat screen or on paper. In contrast, the Diagram Exhibition app provides a true 3-dimensional experience where users can walk around and explore data from every angle. Imagine a field trip to a museum with towering 3D diagrams that students can manipulate. This is the experience that students get from the Diagram Exhibition VR app. Instructors can preload data sets to the cloud, and the VR app visualizes them in virtual reality. Students enter the exhibition building with a code that determines the dataset collection that is displayed. Odd codes are for students and even codes are for instructors. The even codes allow an instructor to advance to a new dataset. Whenever an instructor advances to a new dataset in their headset, the view in the students' MetaQuest headsets changes simultaneously. Currently, the following datasets are available. Introduction to Multivariate Linear Regression, which allows students to adjust a linear regression plane for multivariate regression variable by variable. This only works if the independent variables are uncorrelated. The second collection of datasets will show why this is a problem if we work with correlated predictors. And the third collection of datasets shows the random forest model, including the process of building and using training and testing data. And finally, the last collection of datasets deals with the degree of freedom in regression. Let's go to a demo for the diagram exhibition. I will take the role of the student Henry.
Hi, I am Professor Quant, and I took my students to the diagram exhibition. I chose the dataset collection linear regression and will enter the exhibition with the instructor code for that collection. With the instructor code, I can use the buttons on my right controller to advance the datasets. Whenever I advance to a new dataset, the dataset my students see will change simultaneously. Physically, we are all in the classroom. So, when I talk to my student, they can hear me naturally. Okay, let's go. I will enter my code and then wait for my students to enter on their headsets.
Hi, my name is Henry, and I'm taking a statistics class. Our professor took us today to the diagram exhibition. He gave us a code 590001 that determines which data sets we will see. She has a very similar code, and that code allows her to change the data sets. Let's go inside. Five, 9, 0, 0, 0, 1.
Our professor told us to first explore the dataset. We have a real estate data set here with house prices, conditions of the house, and square footage. When we look at the conditions of the house, we can see conditions get bigger from 1 to 20. Then our data points get higher and higher, and that makes sense because the vertical axis has the house price. When we look at the square footage here, We can see something similar when the square footage increases. When we go from left to right, our data points move up. That means the house price goes up. We can see that in combination way better if we walk inside the diagram, and let's do that. You can see here, when we walk away from the origin, that means conditions and square footage increase, our data points get higher and higher. Let's do something fun. We can try to eat one of these data points. Tastes good.
Hi students, this is your professor. I will teleport you to the red pedestal. From there you can see the data point that are collapsed to a zero condition value. And 1, 2, 3, go.
Here we see the data points collapsed all the way to the front, which means artificially condition was set to 0. That makes it two-dimensional. And now we can use a regression line here to adjust to the data points. This is a pretty good adjustment, I would say. So about 200.
Hello, your professor again. I teleport you to the blue pedestal. 1, 2, 3, go.
We can do the same thing here for the conditions. You see the data points, and these are the same data points. They have been collapsed to square footage equals 0 artificially, and they come all to the front, and we can now adjust here for the conditions. That's a pretty good adjustment, about 17,000.
Hi, your professor again. I will uncollapse and add a regression plane. 1, 2, 3, go.
We see here our original data points, but now there's a regression plane. So we do the same thing that we did before. We adjust step by step, and we can only do that because our regression points are not correlated in terms of condition and square footage. So there's no relation between condition and square footage. Otherwise, that would not work. We use now the left controller buttons to collapse our data, and we collapse them here as before for constant square footage, but now the square footage is the average square footage, so our data points collapse somewhere to the middle. And I adjust the plane in a reasonable way. This looks pretty good to me. And I walk over to the square footage axis and do the same. Again, I use the left controller buttons to first uncollapse the points, and it's not a perfect adjustment, but we haven't adjusted for square footage. Push again on the left controller button, and now we adjust here. The points have constant condition, average conditions, so they collapse in the middle, and we adjust nicely here. And we get a pretty similar result. Again, 217,000. Let's see how that looks for the overall adjustment. So we release collapsing, and we can see we have a pretty good adjustment here of the plane to the data points, and that is exactly what the multivariate regression does. Let's walk inside. And here you can see the adjustment is pretty good. Okay, one aspect is still missing. We said this only works if the independent variables square footage and condition are uncorrelated. How can we find out? We just push a button, and that only works on the student version of the diagram exhibition app. It is the right-hand upper button, and that will teleport us to the top of the diagram. Let's try it. Here we are, standing on top of the diagram, and if we now look straight down, and we push the lower button on the right controller, all our data points will collapse to the ground. You can see that here. And what you see, they are all over the place, so there is no correlation. We could use the upper button of the right controller to go back, but instead, which is way more fun, and don't do that if you have problems with vertigo, go to the edge, look down, and jump. Okay, I hope you had fun with the diagram app.